Hello, my name is Marile Colon Robles. I'm the project scientist for NASA Globe Clouds at NASA Langley Research Center in Hampton, Virginia. I'm also the main author of the recent BAMS paper, Clouds Around the World, How a Simple Citizen Science Data Challenge Became a Worldwide Success. Through this video, I invited other people from the Globe Clouds team to talk a little bit of what we do. You're going to hear from Dr. Brent Dodson, who's a research scientist, and how the methods that he's used to analyze the citizen science data using the volume of data, which is the strength of it, and compared it to satellite observations. And you're going to hear from the data manager, Tina Rogerson. Now, she is in charge of matching, whenever possible, each cloud observation made around the world to multiple satellite observations. So a little bit about GLOBE. GLOBE is NASA's largest and longest lasting citizen science program about the environment. And through the release of the Globe Observer app a few years ago, it's even easier to use observations, and people can use their mobile device to even take photographs of the sky and make observations. And they get notifications of when a satellite flyover will be in their area in order to co-locate better those observations. So I hope that you get to read our paper, get excited about it, and reach out to us. We're more than happy to talk about the data, best practices or tips that we found to use the data in research, and then also about citizen science and how to interact with people and what we've learned about that. Thank you again.
Hi, my name is Brant Dodson. I am an atmospheric scientist at NASA Langley Research Center who uses globe data in my research. I first became involved with using globe clouds data shortly after the 2017 Great American Total Solar Eclipse. I was offered the opportunity to examine the meteorological properties of the eclipse using globe data collected specifically for the event. I was able to show a connection between the cloud cover during the eclipse with the temperature drop induced by the passing lunar shadow. More recently, I have been looking at the data collected during the Spring Cloud Challenge of 2018 and the Fall Cloud Challenge of 2019. Because these challenges were worldwide events, I was able to show how the distribution of clouds changes from region to region of Earth. One of the greatest advantages of Globe Cloud's data is the satellite matching component. Using the satellite match data, I have shown that both globe participants and satellites agree closely on the distribution of cloud cover across the planet. This was a really exciting find that I was not expecting. Related to this work, one of my most important goals is determining the certainty range of the data and the results based on the data. So I've been looking into this, and the good news is that what citizen science data lacks in calibration, it makes up for in volume. The strength of citizen science data lies in the number of participants willing to provide lots of observations to help improve the science. I've been working on some experimental procedures to study this, and what I find over and over again is that as the number of observations provided to globe clouds increases, the messiness of the results drops dramatically, leaving a reliable set of results. I think this sort of research is going to be very helpful in promoting the use of citizen science within the professional scientific community going on into the future.
Hi, I'm Tina, the data manager for NASA Globe Clouds. As the data manager, I'm responsible for managing cloud observation data received from the GLOBE program and matching cloud observations to satellite data. The GLOBE cloud observations are matched to multiple geostationary satellites, Aqua, Terra, and Calypso. Satellite data corresponds to a cloud observation location, and that is within plus or 15 minutes of the time an observation was taken is considered a satellite match. When a cloud observer makes an observation that is matched to satellite data, they receive a personalized email from us here at NASA. The email contains a table that compares the ground-based cloud observation to what the satellite observed. Satellite match emails are usually sent 24 hours to 4 to 5 days after an observation is submitted to GLOBE. It takes several days sometimes to process our satellite data. Thus, this is the reason for the delay. Cloud observations can be matched to multiple satellites, so you might receive more than one email from NASA for a given observation. Satellites can only capture a top-down view of the planet, while ground observers complement what the satellite cannot see. For example, cloud bases, cloud cover, and multiple satellite layers. By putting these two vantage points together, we get a much more complete picture of clouds in the atmosphere. Thank you so much for listening. Y'all have a good day.